In this video, we're going to solve log of x plus 5 minus log 15 is equal to log 18 for x. Now, the first thing that I would do in this problem, if you're not comfortable with the fact that this log doesn't have a base and you know it's the common log, I would go ahead just and write a 10 as your base, because anytime the base is not written in and you have an log, you know it's understood to be the common log, which has a base of 10. So that's the first thing I would do, unless you're just really comfortable with it. The second thing is we need to see what we want to solve for. We want to solve for x, and x is only found inside of this first log right here. And so we know at some point we're going to be changing from logarithmic form to exponential form, or at least that's what we would most likely do in these kinds of situations. But there's actually a faster way to solve this problem. And the way we're going to do it is we're going to use the quotient property on the left-hand side of logarithms. So on the left-hand side, we have log base 10 x plus 5 minus log base 10 of 15. And so whenever you have two logs that are being subtracted, you can combine those two logs, or you can call that condensing, into one log where you divide what is inside of each of those logs. And so in other words, log base 10 of x plus 5 minus log base 10 15 is the same thing as log base 10 of x plus 5 divided by 15. So whatever had the positive log, whatever's inside of the log that had a positive coefficient goes in the numerator. Whatever is inside of the log that had a negative coefficient, in this case the coefficient of this log was -1, you put in the denominator. And so the left-hand side we've now condensed to one log, and the right-hand side we can just rewrite log base 10 of 18. And so now the nice thing about this problem is we have the log base 10 of something is equal to the log base 10 of something. And so since we just have a log on each side and stuff on the insides, the stuff on the insides has to be equal because we have the same operation going on outside of the insides, and that is log base 10. And so those can cancel each other out, and that's going to leave us with x plus 5 divided by 15 is equal to 18. And now we can just solve for x. We can do that by multiplying by 15 on both sides, and that will give us x plus 5 on the left-hand side. And on the right-hand side, that will give us 18 times 15, which is 270. And then we can subtract 5 from both sides, and then we'll be done. So we'll have x is equal to 265. And that's going to be our answer. So there are other ways that you could have gone about this problem if you wanted to move all of the terms to one side and then combine all three of the logs using the quotient properties or potentially product properties for another problem depending on how the signs fall. You could certainly do that too, and then you would be changing it from logarithmic to exponential form if you solved it that way. But anytime you can set it up as log of something is equal to log of something where the two logs have the same base, of course, then you can just cancel them out and put the insides equal to each other. And I think that was a little bit easier for this problem.